When we need to rationalize the denominator, and our denominator is a binomial, we need to multiply by that binomial's conjugate. So you should recall this, but I'm going to write it down for you. Conjugates. So 1 plus the square root of 5 is the binomial. The conjugate is 1 minus the square root of 5. So I'm going to just give you a few examples. The square root of x minus 2 is the binomial. The conjugate is the square root of x plus 2. The square root of x minus the square root of a is the binomial. The square root of x plus the square root of a is its conjugate. And multiplying by conjugates, a plus b, a minus b, multiplying by conjugates results in a squared minus b squared. So if I take the conjugates and I multiply them together, I end up with a squared minus b squared. So we're going to multiply the denominator by the conjugate, 1 minus the square root of 5. And of course, we're going to multiply by that same value in the numerator so that I'm multiplying my original expression by a factor of 1. So in the numerator, I have 1 times the quantity 1 minus the square root of 5. And in the denominator, I'm going to have 1 times 1 minus the square root of 5 times the square root of 5. 1 times 1 is 1. Minus the square root of 5 times the square root of 5 is 5. So 1 times 1 is 1. Square root of 5 times the square root of 5 is 5. 1 minus the square root of 5 over negative 4. Now proper etiquette is going to dictate that we take care of this negative in the denominator. We're going to move it up to the numerator. When we move it up to the numerator, we're going to have the opposite of all of the numerator over positive 4. So we just moved it up to the numerator. And then I'm going to distribute that negative 1 plus the square root of 5 all over 4. And we've successfully rationalized the denominator. Let's try another. Here we have x over the square root of x minus 2. I'm going to multiply by the conjugate of that denominator, the square root of x plus 2. And I'm going to do that in both the numerator and the denominator so that again I'm multiplying by a factor of 1. In the numerator, we have x times the square root of x plus 2. And in the denominator, I'm going to use some highlighters again. The square root of x times the square root of x is x minus 2 times 2 is 4. So our answer is x times the quantity, the square root of x plus 2, all over x minus 4. Nothing cancels out because this x minus 4 is a binomial. It's connected. And the only things that cancel out are common factors, and x minus 4 doesn't have a common factor of x minus 4 in the numerator. Okay, I'm going to go to number 9. I'm going to go to number 9. And let's see if you can, and then we'll go back to number 8. Let's do this one right here. Let's see if you could try this one. Try to multiply this one. Press pause, come back and check, and I am going to explain again because I want to make sure that you get an explanation in case you need just one more explanation before you do your practice. Okay, in the numerator and the denominator, I'm going to multiply by the conjugate of the denominator to rationalize that denominator. And you're going to see that in the numerator, we're going to actually end up multiplying a binomial times itself. So I'm going to go to the easier part here. The easier part happens to be, in this case, the denominator, because we're going to have the square root of x times the square root of x is x, and the square root of a times the square root of a is a. So we've got x minus a as a binomial in the denominator. In the numerator, the square root of x times the square root of x is x. The square root of x times the square root of a is the square root of ax. I'm just going to alphabetize my factors. The square root of x times the square root of a, we multiply the radicants, plus the square root of a times the square root of x. Again, keep those alphabetized. Square root of ax, plus the square root of a times the square root of a, which is a. So in the numerator, we're going to have x plus 2 times the square root of ax plus a. That is a trinomial over a binomial, x minus a. And if you got that for an answer, you did fantastic. Okay, let's try one more. I know I said one more. Let's try one more. And this time you're going to rationalize the numerator. See if you can do this one. Rationalize the numerator. So what would you have to multiply both the numerator and the denominator by to rationalize that numerator? Okay, if you've pressed pause and you've come back, you're anxious for an answer. So I'm going to go right to the answer, 1 over the square root of x plus the square root of 5. And now I'm going to show you how I did that. The square root of x minus the square root of 5 over x minus 5. We multiply both the numerator and the denominator by the conjugate of the numerator. By the conjugate of that numerator. And then what that gives us is x minus 5 as a binomial in the numerator over x minus 5 times the square root of x plus 5 plus the square root of 5. And then look at that. The x minus 5s, those are binomials that cancel out. And what's left in the numerator? 1. And that's how we get 1 over the square root of x plus the square root of 5. Now, this is going to be a little challenging, this homework, because every once in a while you get something that's different than all the other problems. For instance, 1 over the square root of 5 plus 4 over the square root of 45. Like, where did that come from? It came from everything that we've been doing. We're going to put it all together here, and we're going to try and add these two fractions. First thing I'm going to do is I'm going to say 1 over the square root of 5 plus 4 over 3 times the square root of 5. Where did that come from? The square root of 45 is the same thing as 3 times 3 times 5. It's 9 times 5. The pair of 3's, one of the 3's comes to the outside, and that's where 3 times the square root of 5 came from. Now, in order to add fractions, we need a common denominator. So I'm going to multiply the first fraction by 3 over 3. So I've got 3 over 3 times the square root of 5 plus 4 over 3 times the square root of 5. Well, you keep the denominator and you add the numerators. 3 plus 4 is 7. The problem is that we need to rationalize that denominator. So I'm going to multiply both the numerator and the denominator by the square root of 5. 7 times the square root of 5 over 3 times 5, which is 15. So every once in a while, you'll get a problem where you're having to put all of your skills together, even going back to your elementary days of adding fractions with common denominators. So hopefully you found this video helpful, and we'll see you in the next.